Hello everyone, my name is Yamni. I am from Sri Venkateshwara College of Engineering. I am here to explain my seminar topic based on a decision tree based online traffic classification method for QoS routing in data center networks. I am presenting this seminar topic under the guidance of Professor Santosh Kumar sir. These are my contents: introduction, literature survey, methodology, results, applications, conclusions and references. Introduction. Nowadays, traffic classification has been widely studied to guarantee network flow QoS since it is providing a basic for the network performance level requirements for the different flow types. However, traditional traffic classification methods, which can only identify traffic type offline, has no ability to achieve for the online classification and in real-time QoS requirements. In data center networks requires a high level of performance and reliability to ensure that the applications and the server are delivered with low latency and high throughput. QoS, that means quality of service routing, is a technique used to ensure that traffic is routed along paths that met certain performance requirements such as low latency and high bandwidth. However, to perform QoS routing, it is necessary to classify traffic in real time to determine the QoS requirements of the traffic. Decision tree, a rule-based supervised machine learning method, is one of the most popular classification technique in machine learning and data mining. A decision tree model is represented by the sequence of branch statements which continuously judges for the first node, to say the root node of the tree, to reach the leaf nodes of the expected classification label. It is simple, interpretable and efficient. So it is widely used in the classification of network packets because programmable switches have state, maintenance capability and support data size compression in the pipeline of the packet processing. The decision tree algorithm is naturally considered for the real-time classification of the network flows in programmable switches to reduce the complex operations that needed to be used in the training process of the decision tree model. The way of offline training and online development is used to classify the network flow in real time. After identifying the flow type, the programmable switch timely carries out the corresponding QoS routing for the flow according to the real-time link state of the network. Objectives. The general objectives for the decision tree based online traffic classification method for QoS routing in data center are to improve the overall performance of the data center network by routing traffic based on its QoS requirement, to reduce the livelihood of the network congestion and improve the overall network efficiency by prioritizing traffic based on QoS requirement, to provide a scalable and adaptive traffic classification method that can accommodate changes, network conditions and traffic patterns, to evaluate the performance of the proposed method and compare it with the other traffic classification methods in terms of accuracy, efficiency and scalability. Literature survey. In the first paper, short-term traffic speed forecasting using deep learning method based on the multi-temporal traffic flow volume, which was published in the 2022. The main advantage is deep learning models can make accurate prediction about the traffic speed. The model can update traffic speed forecasting in real time. The disadvantages are the model needs high performance computing resources for training and interference. The model can be complex and difficult to understand. In the second paper, Application Awareness QoS Routing in SDNs using Machine Learning Techniques, which was published in the year 2022, the use of the machine learning technique can enable the routing to adapt to change network traffic patterns. Machine learning models requires large amount of data training, which can be a challenge for the QoS routing in SDNs as network traffic patterns may change over time. In the third paper, efficient detection of botnet traffic by feature selection and decision tree. In this approach can be scaled to handle large amount of traffic data from different resources. Efficient detection of the botnet traffic can be achieved in a real time, enabling timely responses to security threats. The approach requires a large dataset for the training, which can be a challenge for the detecting emerging botnets. The approach may overfit to training data, leads to false positives or negatives. In fourth paper, the effective classification of encrypted STKDA network traffic in smart factory using decision tree algorithm, which was published in the year 2021. The main advantage is it automates the classification process and eliminates the need of manual analysis. The disadvantage is decision tree algorithm may be competitive intensive, requires high performance computing resources for training and inference. In the fifth paper, the online encrypted mobile application traffic classification at the early stage challenges evaluation criteria compresses methods, which was published in the year 2021. The advantage is this approach can automate the classification process, eliminates the need of manual analysis. The encrypted mobile application traffic classification can be challenged due to the use of the encryption. We can limit the accuracy of the traffic classification models. In the paper 6, the traffic classification for effective load balancing in the server cluster using deep learning techniques, which was published in the year 2021. In this, the traffic classification can be achieved in the real time, enabling timely responses to changing traffic patterns. The approach can automate the traffic classification process, eliminates the need of the manual analysis. The main disadvantages of this is the approach requires a large dataset for the training, which can be a challenge for the detecting the emergency traffic patterns. These three, the fourth, fifth, and sixth papers avoids the manual analysis, which is an online process. Methodology. A decision tree based online traffic classification method is a technique used to classify traffic based on the QoS requirement. The method involves constructing a decision tree that classifies traffic based on the features, packet size, packet type, and source and destination IP address. The decision tree is trained using a set of labeled traffic class samples, and once trained can be used to classify traffic in real time. The data set is formed by extracting the related features of the first n packets of each network flow from the original offline network traffic traces. Using the data set, the decision tree model is trained offline, and then the model is used to realize the online real-time classification of the network flow in programmable switch. Block diagram. The construction of traffic QoS routing system based on online decision tree classification is mainly divided in three steps. Decision tree model offline training. In this, the future extraction of the first n packets of the flow in traffic files are used as a dataset to train the initial decision tree model. Since the initial decision tree model is a high complexity and can't run efficiently in programmable switches, it is necessary to optimize it to obtain a suitable decision tree model for online classification. P4 switch configuration. P4 switch is also known as programmable switch. Based on the original forwarding rules of the networks, network administration enables the decision tree into P4 code logic and configures that the switch that supports the online flow classification for QoS routing with compiled P4 flow online classification and QoS routing. In programmable switch that supports flow classification information such as size and arrival time of the first n packets of the flow is recorded, and relevant features are extracted for classification. The forwarding rules for the first n packets use the default path, where for subsequent classified packets the switch reroutes them to the path with QoS guarantee for the forwarding. Flow algorithm. This flow algorithm can be implemented in real time using combination of hardware and software components. This involves several steps. Data collection is the first and foremost step. In these steps, we are going to collect the data in different types, that is such as web data, file transport data, streaming data, and IP address data. These are the types of data we are going to collect in this. In the next step, we are going to extract the future. Once the data is collected, the relevant features of the traffic classification are selected. The selected features can be included packet size, packet type, source and IP addresses, source and IP ports, and other protocol specific features. Next, the data collected is divided into two parts, training data and testing data. The training data is labeled with the correct QoS requirement for each packet or flow. Using the training data, a decision tree is constructed to classify traffic based on the selected features. The decision tree is trained using machine learning algorithm which analyze the training data to determine the best split points for each node in the tree. Once the decision tree is constructed, it can be used to classify traffic in real time. As new packet or flow is observed, they are passed through the decision tree to determine their QoS requirements. Based on the QoS requirements determined for each flow or packet, QoS routing can be performed to select the best path through the network that meets the QoS requirement. The performance of the decision tree based on online traffic classification method is evaluated using the testing data. The accuracy is measured as well as other performance metrics such as performance time and scalability is measured. Result. In terms of traffic classification, the decision tree based approach achieves high accuracy rate with an average accuracy of 95% with different traffic types. This is a significant improvement over traditional methods that rely on the simple packet header based classification, which may not be able to accurately differentiate with different types of data. They compared the proposed method with three different traffic classification methods, Navi biased SVM, that means a support vector mechanism, and random forest. Moreover, the proposed method was found to be effective in reducing the network congestion and improving the network throughput by routing traffic flows according to their QoS requirements. Applications. This is mostly used in cloud computing, Internet of Things IoT, video streaming, and online gaming. Conclusion. By using a decision tree model for online traffic classification, the method is able to handle complex relationship between packet features and traffic classification, results in high accuracy rates. That results shown that the proposed method outperformed the other methods in terms of accuracy, precision, recall, FN score. Moreover, the proposed method was found to be effective in reducing the network congestion and improving network throughput by routing traffic flows according to their QoS requirements. The method was also shown to be computationally effective and capable of real-time implementation in data center networks. The proposed decision tree-based online traffic classification method is promising approaches for QoS routing in data center networks. References. These are my 6 references which I gone through for this seminar topic. Thank you for spending your valuable time with me.